All right, today we're diving deep into one of the biggest goals in all of science, building a true artificial general intelligence, or AGI. We're going to explore why the incredible AI we use every single day is, well, more of a brilliant impersonator than a real thinker, and what it's actually going to take to finally bridge that gap.
It really all goes back to this one question, asked over 70 years ago by the legendary Alan Turing. It's the challenge that kicked off this entire field and has been the driving force behind AI ever since.
And let's be real, the progress we've seen is just staggering. I mean, models like GPT-4, DeepSeek, and Grok 3 can do things that honestly feel like magic. They've got this fluency, this capability that was pure science fiction just a handful of years ago.
But that brings us to the fundamental question, the one that researchers are wrestling with right now. Is what we're seeing genuine, human-like thinking? Or have we just built the world's most sophisticated parrot? That's the core puzzle we're going to unpack.
Okay, so let's get into it. To really understand where AI is heading, we first need to get a super clear picture of how the models we're all using actually work under the hood.
What's so wild about this timeline is the acceleration. You see decades of slow, steady progress, and then bam, 2017, the transformer architecture drops, and it just changes everything. It's what led to this absolute explosion in generative AI, and what's setting the stage for what many believe is the next giant leap, agentic AI.
So how does this magic trick actually work? Well, at its heart, it's all about statistics. These large language models, they're not really understanding ideas. They're incredible pattern matchers, predicting the next token, which is basically a word or part of a word, based on the trillions of examples they've seen.
In this chart, it lays out the exact gap we need to close. Token prediction is amazing at mimicking how we talk and write, but it has no idea about cause and effect. It has no body, no way to interact with the world. Grounded reasoning, on the other hand, is all about understanding the why behind things. And that's what you need for real planning and problem solving. So, this leads to a pretty critical question, right? If this whole token prediction thing has gotten us this far, why can't we just keep making the models bigger and bigger and bigger until we just stumble into AGI?
Well, the research is pretty clear on this one. Bigger isn't better. Just scaling up doesn't fix the fundamental problems. It won't magically give an AI long-term memory or sense of self or the built-in gut feelings, what researchers call inductive biases, that you need for structured thinking. It's an architectural problem, not a size problem.
And get this. Here's a perfect example of why architecture is the real game changer. Researchers gave a super complex puzzle to GPT-4, one of the most powerful models out there. It only solved it 4% of the time. But then they added a new reasoning framework on top of it. Suddenly, the exact same model jumped to a 74% success rate. That just shows you the power of a better blueprint.
So if the current approach has a ceiling, where do we look for a new blueprint? Well, it turns out the inspiration might be a lot closer than we think. In fact, it's right inside our own heads.
That's right, the human brain. It's not one giant do-it-all computer. It's more like a complex team of specialists, all working together efficiently. And that modular design is what's inspiring the next wave of AI. And we've actually been doing this for years. AI that sees the world, that's inspired by our occipital lobe. AI that understands sequences and memory, that's kind of like our hippocampus. And AI that learns to plan and make decisions, that mirrors our prefrontal cortex. The next big step is getting all these pieces to work together in a much more integrated way.
So this whole idea of taking cues from the brain is leading to a massive shift. We're moving away from these static models that just sit there and answer your questions, and moving towards dynamic systems that can actually go out and do things. And that brings us to agentic AI. The difference here is huge. Think about a calculator versus a detective. You ask a calculator a question, it gives you an answer, that's it. But you give a detective a goal, like solve this case, and they make a plan, they gather evidence, they adapt. That's what an agent does. It pursues a goal.
And they do this using a constant loop. They reason about a task, they take an action, like using a tool or looking something up, they observe what happened, and then they update their plan based on that new info. It's a cycle of reason, act, observe, and it lets them learn and adapt on the fly, just like we do.
And this idea has just opened the floodgates to all these cool new architectures. We're seeing models that are trained to think before they answer, systems that have a whole team of specialized experts inside them, and even entire societies of AI agents that can work together to tackle really complex problems.
Okay, so this new world of agentic AI is bringing us closer to AGI than ever before. But as these systems get more and more autonomous, a huge question comes up. How do we make sure they're on our team?
Well, it really boils down to 3 absolute must-haves. First, the tech has to be robust, reliable and secure. Second, it has to be aligned with basic human values. And third, we need to be able to look inside and understand how it's making decisions. You can't have one without the others.
One of the main ways we do this is with something called reinforcement learning with human feedback. Basically, you have human trainers who act like teachers. They rate the AI's responses, giving it a thumbs up for being helpful and harmless. That feedback helps bake our values right into the AI's core programming.
And the researchers behind this work really drive this point home. Getting the stuff right, the ethics, the safety, the alignment, it isn't just a nice-to-have feature. It's an absolute necessity if we want this technology to benefit everyone and not just make existing problems worse.
So in the end, this whole quest for AGI, it forces us to look in the mirror. It's not just about what we can build, it's about what we should build. It's a journey that's going to define not just the future of our technology, but the future of all of us.